In this video, we're going to discuss DNS. DNS can be a very large topic and somewhat difficult, so we'll try to make it simple here and give you some resources. There are a lot of resources, and we could again really spend a lot of time on this, but I'm hoping you get a basic understanding of what DNS is. We'll spend most of our time with the on-premise local server and how local DNS works. However, there is an Azure component of DNS and private zones and virtual links that I'll mention here very briefly as well. I think to kick off our DNS discussion, I just want to discuss some of the pieces of material that I have here. So I have the official Microsoft curriculum. Again, this came from a blog post that had several links to help prepare yourself for the AZ 800 exam. The first of these, integrating DNS with Active Directory, managing, creating zones and records, configuring and forwarding conditional forwarders, are all kind of based around on-premise DNS servers. Then there's a couple, or one section I should say here, which can lead into several rabbit holes as you click into links, about integrating DNS with Azure DNS and private zones. And then there's a section about DNS security. What I'm going to do right now is just go into a PowerPoint slide presentation that I have. It's from a different class that I taught and just kind of covers some of the basics. There is a lot of slides. I'm going to skip around here a little bit, but hopefully you can stick with me and again understand a little bit about DNS. So in simple terms, what DNS does for us is it resolves names to IP addresses. There's some other functions as well, but at its simplest, it resolves names to IP addresses. So for example, if I want to go to Facebook, I can simply type in facebook.com and I can hit enter. What happens is facebook.com gets resolved or translated into an IP address. I always say computers don't know the English language. They don't know what facebook.com is or espn.com or yahoo.com. That's not a language they speak. They speak binary, ones and zeros. So what actually happens here is, let me open my command prompt and just show you, is when I go to Facebook, that facebook.com actually gets resolved to an IP. And so one quick way to get the IP is to ping it. You can also do an NS lookup, which I'll do here as well with a different one. But I can see here that facebook.com is actually 157.240.26.35. Now I'm likely going to get an error if I try this, but I'm going to try it anyways. Theoretically, I could save my computer a step from having to resolve facebook.com by just typing in its IP address. Telling me it's not secure because of the certificate, but it actually did work. It's resolving me to facebook.com here. So any website that I go to, my computer is going to do a DNS query, as it's called, to find the IP address. Another command that we have is called NS lookup. So maybe I want to find what the IP address of google.com is. And I'm getting my DNS from Midco because I'm a Midco customer. So this is the IP address of the server, of the DNS server. And I'm getting what's called a non-authoritative answer. So it says, I think I know who google.com is. Here's its IPv6 address and here's IPv4. The reason why it's a non-authoritative answer is because this server doesn't actually host this zone. Google's server hosts this zone. So if I was actually querying Google's DNS server, I would get an authoritative answer saying I know for sure because it's me. But this is essentially a best guess, and it's a good guess. It's the right guess, but it's considered a non-authoritative answer. So at its simplest, what DNS does for us is it resolves names to IPs, and it was really developed to make life easier for us because when we access resources, websites, servers, those sorts of things, it's easy for us to remember, say, a google.com, a yahoo.com. That's much easier than to remember 157.240.26.35. Imagine if you had to type that in every time you wanted to go to Facebook. Or let's say you created a new website. Let's say I created a new website, matt.com, and I wanted everybody to go to matt.com. Well, without DNS, I would have to say, hey, why don't you go to my new website? It's 34.67.12.6. You'd get to your URL browser here, or your window, and you would start typing in, well, what did I say again? See, I can't even remember, and I said it 2 seconds ago. So I remember matt.com, though. It's, makes it simple. So that's what DNS does for us. It's also a resource locator, especially in an Active Directory domain. Who is the DNS server? Who is the Active Directory server? Who is the DHCP server? It can help us find some of those resources on the network. So I mentioned some of this already. At the very top of the DNS namespace, we have what's called a domain. And what a domain does is it kind of separates off a distinct network, is one way I will describe it. So I'm just going to pull up my server here, and this is my server 2022 machine, and I have installed what's called Active Directory. We haven't quite got to that yet, but I also have DNS installed. So when you install Active Directory, which you guys will or already have, you would have DNS installed. So here is the DNS console. Just get this open. And right here, this is the name of my server, server DC. I can see that it is a DNS server. I have right here under forward lookup zones, here is my domain. So all of the records for contoso.com would be listed in here. So if anybody requested, let's say, hey, I want the IP address of serverdc.contoso.com, that query could come to this server. This server would be authoritative for it, because it's what's called a name server for contoso.com, and it could respond with the IP address. So other clients, printers, other servers would be listed in here with records. I also see this underscore ms dcs.contoso.com. This is something specific for Microsoft and Active Directory. We won't worry about that right now at this point. So this is a domain. This is a forward lookup zone. A forward lookup zone is names to IPs. A reverse lookup zone would be an IP to a name. Now we'll talk about the different types of records in here in a little bit. Right now I don't have a reverse lookup zone. I have trust points. This has to do with DNS security. And I have conditional forwarders. So typically what happens is within your network, within your organization, you will set all of the clients to have this machine as the DNS server. So let's see what the IP address of this machine is again. So for all of the clients in my contoso.com company, let's pretend contoso.com is a sales organization. So for all of the computers in the contoso.com sales organization, they would use the IP address of 192.168.40.130 for DNS. So they would send all of their queries to this server, and it would be able to resolve currently all of the queries for anything in Contoso. Well, what happens if it tried to go to like ESPN.com? What would happen? Well, since it does not host the zone ESPN.com, what it will do is it will either go out to a forwarder, which currently there is a forwarder set up. If the forwarder is not set up, it would go out to what's called the root hints. This is usually what happens. is we'll go out to a root hints server. And a root hints server is a publicly maintained domain server. So if I did a quick Google search for root DNS servers, and I did a quick image search, I could see where all of these root hints or root DNS servers are located. You can see they're kind of all over the world. So if my server can't resolve, it will typically either go to a forwarder. That's the first thing it looks for. I'll try to forward that query to a different server. If no forwarder is set, it will go out to the root hints. Well, what a conditional forwarder is, conditional forwarder forwards based on a condition, and usually that condition is a domain name. So if I want all google.com queries to go to a specific server, I can set that up here. If I want all Adatum, that's another sample Microsoft domain that you see along with Contoso. If I want all adatum.com queries to go to a specific server, I could set that up so that those get forwarded to that specific server. Any other queries would either go to the root hints, or if I had a different forwarder set up. So within the DNS process, I have a resolver, which is basically asking the question, who is Contoso.com? Who is server dc.contoso.com? Who is google.com? Who is webserver.google.com? That's the resolver. That's your host. That's your Windows machine. That's your IP phone. Then you have the DNS server, which is known in this example here as just a relay, because it's actually going to forward to an authoritative server. We always want to try to get an authoritative server answer. Sometimes we get a non-authoritative, which is just a best guess again. So at the very top we have, in terms of DNS, we have what's called the root DNS. Then we have our top level domains, so our .coms, our .bizes, our .orgs, those sorts of things. There's a whole bunch of different ones now. And then we have our second level domains. Our second level domains is what we actually purchase and register. In terms of an internal private DNS server, that could be anything. So I didn't have to go and register Contoso.com. That's completely fine because this isn't going to be used out on the internet. But if I want to have a domain and a web server that is hosted out on the internet, like I want people to get to matt.com, I would have to go and register that domain. And so a common domain registrar is GoDaddy. Let's pretend I want matt.com, which I think is taken, but we'll look. So I can't buy matt.com, but it's telling me I can hire a broker to try to buy it for $69.99. So other things that are available though: matt.shop, matt.tech, matt.site.space, matthew.online, matt.website, matt.xxx.store, matt.london. These are all available for me to buy. These are actually pretty expensive. Usually you can buy a domain for around 20 bucks a year. Let's what if I did Bismarck matt.com, whoops, .com. Well, looks like I can make it mine. It's only 1 cent for the first year with a 2-year registration. I can buy all 3 of these if I wanted for $21.12. So in the beginning, when DNS was first developed, there's only a few top levels like the .net, the .coms, the .orgs. But as the internet kind of exploded, they went into the other top level domains, like we saw the .bizes, the .sites, the .fms, the .onlines. There's really a ton of them now. Here's some more of those: Aero, Biz, Co-op, Asia, Cat, Mobi, Tel, Travel. A lot of different ones. This is just going through kind of the DNS communication process. Essentially what happens in most cases is it's going to keep trying. It's going to do what's called an iterative query to go and keep trying and finding that name that you're looking for. Eventually it might time out or not be able to resolve, but it's not just going to go to the local server and then stop there. It could go again out to the root hints or out to a forwarder. Skip ahead here a little bit. When a server gets a response from another server, so for example, I went, let's go back here. So for example, if I had a client on my Contoso.com organization that made a request out to Google.com, I can't respond to that query with an answer because I don't host that zone. So then it goes out to the root hints. Root hints would find the answer for me and respond back to this server, and this server would ultimately respond back to the client that requested it. Once it does that, it will put that in a cache. So the next time that someone else on the network goes to Google.com, it doesn't have to go through that whole process again. So it will be in that cache. A client also keeps a cache of DNS queries that it has made. And if you ever needed to clear your cache on your client, you could do something like this: ipconfig/flush DNS, and it would flush that cache. So it's not every single query is going to go through that entire process. Usually it would be inside of a cache. Talked about some of this already. So designing a DNS deployment. So every computer on a TCP/IP network needs access to a DNS server. That's a little false. You wouldn't need to, but it would be very hard to make things function and to navigate. But every computer will typically have a DNS setting within their IP address settings, and that will usually be an on-premise local DNS server. Now it could be an Azure AD server, or sorry, I shouldn't say AD, but an Azure VM server as well. But usually it's an on-premise DNS server. Now the DNS server could be Windows-based and Active Directory integrated like ours, or it could be like a Linux system running DNS as well. Usually at home, what you're going to have is your internet service provider providing the DNS for you. If you want to see what your DNS server setting is, you can go out to the command prompt and you can do an ipconfig/all. And I'm on wireless. So my DNS server right here, this is Midco 24.221.100 is the primary, and the secondary is 24.221.101. So I don't have a local server. I don't have a local network really set up other than some computers and some wireless access points. So for me, what happens is I go out to my internet service provider. My internet service provider hosts a DNS server. They have a lot of domains and queries cached because all of their customers also use this. So I can resolve domain names relatively quickly. This is just kind of showing how that's working. You'll resolve to your ISP, internet service provider's DNS server. If they don't have it inside of the cache, well, it's going to keep going out to the internet root hints servers and try to get the answer for you. Let's pretend you're a company, you're Contoso.com, and you want to have an internal network, Contoso.com, like I do. This actually probably is not best practice, because if I would, let's say, have a web server where people could type in Contoso.com, the name resolution is going to get a little confused for my internal clients, because it's looking like I'm hosting a public domain. And while you can do that, it's probably not the best practice. Who usually hosts your public domain records is your domain registrar. So if I went and I purchased a domain name from GoDaddy, they would give me a DNS server that would list contoso.com and then the name of the server that's hosting my website. So for an internal domain name, you'll typically see something like activedirectory.contoso.com, or you could see something like say contoso.lan or contoso.int or int.contoso.com for internal. But you can use whatever internal domain name that you want. But if you are going to have a public internet presence, this usually would not be best practice. So one advantage to hosting your domain on your own DNS servers is the ability to modify your resource records at will. Again, I probably wouldn't do that. I usually don't. What I do is I use a commercial domain hosting service that provides a lot of reliability, redundant servers, and I can still set your DNS records through their typically a website. What we have done and what we are doing in this class is we're hosting an Active Directory domain because our computers are going to be part of Active Directory. We want to utilize Active Directory users and computers, so we can create user accounts and computer accounts, and then our users can log into any computers across the organization. In order for that to work, you install the Active Directory DNS, Active Directory Domain Services role. That in turn installs this DNS server and all of these different records. What's important for Active Directory is the SRV records, a service locator. Who's hosting LDAP? Essentially the Lightweight Directory Access Protocol. Who's hosting Active Directory? Well, it's this machine right here. So when clients on the contoso.com network need to find an Active Directory server so they can log in, so you can log into a machine, it's going to look for what's called an SRV record. So those are important. Many times what you will do is you'll integrate DHCP on your network with DNS. So as clients come into the network, you want those clients to have their computer name and their IP address inside of DNS. That way, if other computers on the network are trying to locate them by name, they would automatically show up here. If I do not integrate DHCP with DNS, I would have to come in here and create all of my clients separately. So let's pretend I have, client number one. Whoops. Client number one. I would have to map his IP address inside of DNS. And then I have client number two, and I would have to do this manually, and that's going to be very time consuming and a pain. So now when someone on the network tries to, let's say, ping client 1, it's going to resolve to 1.1.1.1. Or let's say client 2 is running a web server. When someone goes to the URL of client2.contoso.com, it's going to resolve to that IP address. So if you integrate DHCP, and DHCP automatically gives IP addresses to clients as they come onto the network. We'll talk about that in a different section of the class. It's going to automatically register those clients with their IP addresses inside of here. This is just talking about creating internet domains, registering that that domain name. Again, an internet domain, ESPN.com, Google.com, Gmail.com, those are a little bit different than internal domain names like we are going to be working with in this class. I think we are going to be using contoso.com. But if you think of like umarry.edu, they have two types of domains. They have an internal domain, which is umarry.edu, and they also have an external domain, umarry.edu. Externally, or public-facing, umarry.edu takes you out to web servers. It takes you out to their home page. I don't know exactly where that domain name is hosted and where that public facing zone is hosted, but we'll pretend it's GoDaddy. They also have an internal umary.edu. So all of the computers on campus, like my laptop, for example, the computers in the lab are connected to the umary.edu internal domain. And so what that allows us to do is find all of the resources internally on the umary.edu domain. So other client computers, user accounts, printers, those sorts of things. Some things to keep in mind when you are creating domains, whether they're external or internal, is you want to keep your domain name short. You don't want to be able, you can have long domain names, but if you have to reference those in scripts or when you're logging in or email addresses, those sorts of things, you don't want to have a long one. You want to avoid an excessive number of domains. You want to create a naming convention and stick to it. You want to avoid obscure abbreviations. You also want to avoid names that are hard to spell. It's going to go a long ways in the end to make administration of that network just simpler. You can create subdomains if you wanted. So right now I have contoso.com. Let's pretend that contoso.com is currently in Bismarck, North Dakota. But then I go and I buy let's say, sister company or another company, and it's in Fargo. And I also want to call it contoso.com. But I want to keep the Fargo records separate from the Bismarck records. So one thing I could do is I could come in here and I could create a new subdomain and call it fargo.contoso.com. And within fargo.contoso.com I could have all of the computers and records for for Fargo in that section. And actually I think I created that a little wrong. I would do a primary lookup zone, and I would do something like this actually. And I would have that separation. Here's fargo.contoso.com. It's going to have all the computers and resources in Fargo, and then I would have contoso.com, which would be all the resources, let's say, in Bismarck. I'll clean that up later. So here's an example, contoso.com externally. And here's some internal domains. Again, a domain is kind of a separation of administrative control. Separation, I don't want to say separation of trust because we can trust between domains, but separation of control. So to deploy or actually install a DNS server, what you can do is you can add the DNS role separately. What we did and what we will work with in this class is an Active Directory integrated zone, which automatically created that. But if you do not have Active Directory, you can just go ahead and you can add the role. Then from there you can create your zones. Again, if you want names to IPs, it would be a forward lookup zone. And if you wanted IPs to names, it would be a reverse lookup zone. So a zone is an administrative entity you create on a DNS server to represent a discrete portion of the DNS namespace. Zones always consist of entire domains or subdomains. So these are zones that you would create. Contoso.com would be a zone. Those are considered valid zones. We have primary zones. Primary zones contain a master copy of the zone database, so a master copy of the records. A secondary zone is just a duplicate. I cannot go to a secondary zone and make changes or add new records. I can only do that on a primary zone. What we have is an Active Directory integrated zone, and so if you had multiple domain servers out there, they would all be running DNS and they would all have what's called an Active Directory integrated zone. With an Active Directory integrated zone, this idea of primary and secondary zones just kind of go away, because everything in essence is a primary zone. I can go to any Active Directory server and make changes if I wanted to. So when you go and you create a new zone, you'd put the check in there if it's Active Directory integrated. If not, you choose primary, secondary, or what's called a stub zone. The records inside of Active Directory. These are important to understand. I have what's called an SOA record. This indicates that the server is the best authoritative source for data concerning the zone. I have, well, I'll show you that here in just a second. I also have a name server. This identifies the authority for the zone. So who is the authority for that particular domain. I have A records and quadruple A records. This is for IPv4, a name to an IP, computer name to IP, computer name to IPv6. I have a pointer record. A pointer record would be the opposite of an A record, so it would be an IP to a name. I have a CNAME or concatenal name. This is an alias. So for example, the real name of my server is server DC. But if I also wanted to be able to reference this server as, let's say, Batman, I can create a CNAME. So let me do the CNAME here first. So CNAME, and Batman is going to resolve to server DC. So now what I could do is I could come to my command prompt and I could ping Batman, and it's actually pinging the IP of server DC. I said I was going to show the SOA record. Here's a SOA record, start of authority. What the start of authority shows is who the primary server is, who's that authoritative server. The serial number is important for syncing changes between servers. So what servers do is they look to that serial number to see if it has been incremented, and let's say it went from 19 to 20. The server looking here would know that there's been one change on this DNS server, and it must go sync that one change. We talked about NS records or name servers. This is the exact server who is authoritative. It happens to be this same server. Okay. So the SOA record and the name server are the same here because I'm only using one machine. So just showing some screenshots on how to create those records. So hopefully that gives you a little quick crash course into an on-premise DNS server. I realize I'm probably not doing it justice. There's a lot to it. Again, my goal here is just to introduce you to it, give you a little bit of understanding on what it's doing, resolving names to IPs, giving us service resource locators, telling us who the authoritative server is, what's a primary zone versus a secondary zone versus an Active Directory integrated zone, what's a forward lookup zone versus reverse lookup zone, what's a forwarder, what are the root hints, those sorts of things hopefully you have a decent understanding of. As I mentioned, there is a component of Azure DNS here that I'm not really covering in depth in this class just because we don't really have a great environment to simulate Azure AD, but I do want to mention a couple things here. So let me just go out to a link. So with Azure Active Directory, Azure DNS, I should say, and Azure Active Directory, I suppose, you potentially could have virtual machines out in the cloud being hosted by Microsoft. And you would want your internal clients to be able to resolve those names of those virtual servers. So for example, in this screenshot here, there are two VMs. There's VMnet A and VMnet A2. And those are actually Azure hosted virtual machines. They're not on the physical network, so they're not on-premise devices. But I want my client internally to be able to access those. So one thing I can do is I can set up what's called an Azure AD private zone, so a private DNS zone. And essentially how that works is, I believe through forwarding, is the internet client, you would set up a forwarder, a conditional forwarder. When it tries to access this particular VM, it would go out to the Azure DNS private hosted zone and then be able to resolve to that VM's name. Otherwise, that client would never be able to find it because it has an internal IP, and internal IPs aren't out on public DNS servers. So there's a lot of links on Azure DNS, and you can kind of get lost in them a little bit. But I would encourage you maybe just to read through a few of these, and it will talk a little bit about how it works and how that name resolution process plays out inside of what's called a hybrid environment, where you have on-premise servers and devices, and then you have VMs out in the cloud. Here's actually the screenshot I was looking at. So I have on-premise devices. They want to access VMs that are being hosted out in Azure. So their query for the VM goes to their local DNS server. The local DNS server forwards it out to an Azure DNS server. That Azure DNS server can then go and find the particular clients that they're looking for, and that process can resolve back. You have to typically have what's called a virtual link in between your on-premise and your AD zone, or sorry, your Azure environment. So anyways, I don't want to get too deep into the weeds with that. My main focus right now is on-premise DNS, how that looks, how that works. Hopefully after going through this, reading the material, and then doing the labs, you'll have a decent understanding of what DNS is and how it works. That's it for this video. Thanks for watching.